Hi everybody. Okay, this video is about earthquakes. Okay, we're on page 394. Okay, so at the top you see there's a picture of a seismograph, and that's used to record and predict when earthquakes are going to occur. Kind of a funny looking machine. Almost looks like a heart rate monitor that they would put on you if you were in the hospital or something like that, because it makes lines like that. The more the earthquake is, or the higher volume the earthquake is, the more it's going to go up and down those lines. So this does bounce off the topic of tectonic plates, if you watched my previous video, I talked about tectonic plates and shifts in tectonic plates and boundaries can cause earthquakes. So let's read along. Movement of whole tectonic plates is very slow, but once in a while a small piece of earth can shake enough to crumble buildings to the ground. A fault is a break in the earth's crust where the rock on one side can move in relation to a rock on the other side. As plates move, pressure builds up along the fault. When the pressure becomes too great, the rock on one side of the fault suddenly snaps free and slides past the rock on the other side. This release of energy and shaking of the ground is called an earthquake. Okay, so if you look at the diagram below, it says focus. That's where the plates are sliding past each other, okay? But and the fault is right at the top, right where the Earth's crust is, and then, but just because the focus and the fault are there, it could reverberate very wide distances. So you see the city is not really right by the fault, but it will still be affected by an earthquake because it's so strong and powerful. Okay, on to page 395. Okay. The point inside Earth where an earthquake begins is called the focus. The energy from an earthquake travels away from the focus in waves. That's why in that picture it was kind of like showing like almost like a ripple effect. Okay, it had a bunch of circles going out and out, farther out. Okay. When the energy waves reach the surface, the ground shakes. The point on Earth's surface directly above the focus is called the epicenter. Earthquake motion is most severe at the epicenter. Smaller waves of energy occur near the focus before an earthquake. The tremors may not be felt at the surface, but a device called a seismograph, which you see at page 394, it can graph them. Okay, and then scientists can use a seismograph to predict if an earthquake is likely to occur. There is no way to prevent earthquakes, though. To avoid injuries during an earthquake, avoid buildings, bridges, or other structures that are likely to fall down. Earthquakes can be dramatic and cause great damage to built structures. So unfortunately, there's no preventative measure or way to prevent earthquakes. All you could do is get away from, buildings and bridges and things like that are, like they said, are likely to get damaged or fall down. Go down to basement, where you're safest. But the good thing about a seismograph is it can give people some warning. So if they see some activity beneath the surface, they could put out an earthquake warning and get people out of harm's way, hopefully. So for this little graph on the bottom of page 395, it shows two readings from a seismograph. It says, compare with what the motion of the ground was probably like during these two earthquakes, as shown from a seismograph. Now remember, I said the more it goes up and down, that's the more severe one, right? So that should give you a hint on how to answer this question. The one on the top, you could see the lines aren't as big. They don't go up and down as violently. So compare those two. Which one looks like it's going to be a worse earthquake, a greater magnitude. Okay, so speaking of magnitudes, 396, page 396 says measuring earthquakes. Okay, how do scientists describe the strength of an earthquake? Do they measure the size of its energy waves? Do they figure out the total amount of energy it produces? Well, they do both. An earthquake's magnitude is the amount of energy it releases. The Richter scale measures the magnitude of earthquakes on a scale of 1 to 10. So it's a pretty straightforward scale. The higher the energy waves, the higher the number, and the more severe the earthquake. The scale uses the size of waves on a seismograph to determine an earthquake's strength. An earthquake that measures 2.0 on the Richter scale is too mild to feel. About 8,000 earthquakes measuring below 2 on a Richter scale occur every day, and we don't even notice them. Okay? Obviously, this picture, it was not a 2.0. You can see there was great damage in here, and this was an earthquake that happened in Italy in 2009. And you could see the damage that an earthquake, powerful earthquake, can cause. Okay. Each 1 point, I'm on page 397 now. Each 1 point increase on the Richter scale means an increase of strength of about 31 times. Okay, so if you're thinking about times tables, that means you're multiplying that number by 31. So it varies greatly. So like a 2 to a 3 to a 4 is a big difference. It gets a lot more powerful, okay? An earthquake measuring 6.0 or higher on the Richter scale can cause heavy damage in populated areas. Earthquakes measuring 6.0 or stronger occur about 120 times a year. The Richter scale was developed in 1935, a long time ago. Scientists have since developed a more accurate way to measure the magnitudes of larger earthquakes. The moment magnitude scale uses a mathematical formula to calculate the total energy that an earthquake releases. The moment magnitude scale also assigns numbers between 1 and 10. As in January of 2010, an earthquake measuring 7.0 on the moment magnitude scale caused catastrophic damage to a densely populated area in Haiti. So on the top of the page, you could see the presidential palace where the president of Haiti stays. Before the earthquake is on the left, and then after. It's pretty destroyed, okay? That was a pretty big one, okay? So for the question where it says, explain which of these locations would experience greater earthquake damage, okay? They show a picture of the city and then the picture of the country, okay? What do you think would cause more, what's gonna be damaged more? A city or a country based on what you've learned? So the country, there's not a lot of structures, as many structures, I guess I should say, as in a city. So that should help you answer that question, okay? And then next week we're gonna pick this up, this topic of Earth's surface and Earth's layers, and we're gonna continue it with volcanoes, okay? So thanks for watching, and talk to you guys next week.